Hello, everyone, and welcome to today's webinar. My name is Danny Tsidoni. I'm a product enablement specialist at NetApp, and with me is Esti Lipkin, who's a cloud solutions architect at NetApp.
Hello, good morning, and thank you for joining us.
Thank you for joining me, Esti. Today, we're going to talk about disaster recovery made easy with Amazon FSx for NetApp ONTAP with BlueXP Workload Factory. Before we're talking about the specifics, I'd like us to get started with disaster recovery in a nutshell and set some ground terms that will help us throughout the webinar. So first of all, what is a disaster? I'll define a disaster as an interruption of our daily business process. Disaster recovery is our ability to mitigate the disaster and get back to business. A DR plan is the technical plan and the processes that enable disaster recovery, part of our business continuity plan. A DR site is therefore a secondary site, typically in a geographically remote place from our production site, where we can fail over to and mirror our business data in case of a disaster. And a cloud DR site is a DR site residing in a private cloud or in one of the hyperscalers. In our case today, we're going to talk about AWS. So our cloud DR site is naturally residing in AWS for this webinar's purpose. One of the As you might have guessed, disaster recovery is not a straightforward issue, has some challenges, especially when we're working on different applications, whether they're stateless or stateful. So let's talk a little bit about common challenges when it comes to getting our applications ready for disaster and able to recover from disasters. So first of all, there is complexity. There's a need to synchronize many moving parts and making sure that multiple components are ready for a disaster and ready for the failover should it happen. Because of said complexity, downtime could also be quite an issue. Restoring an entire application stack could take us a while, and specifically when we have complex applications with large data sets. And you also have unique considerations if you have a few applications or several applications that you need to recover, or fail over to. If the disaster is, let's say, a disaster that is in your entire data center, then different applications have unique requirements and dependencies that you need to fail over to get back to business. And last but not least, complex disaster recovery testing. It's all nice to have a DR plan, but if you don't test the plan, you don't know if if you don't test the plan in, let's call it, practice conditions, you are almost sure that it's not going to work in real time. So testing the application in a live environment is risky on the one hand, and on the other hand, creating copies in DR is complex. It's taxing, both when it comes to our time and financially. So what does FSx for ONTAP has to offer for disaster recovery? First of all, as an ONTAP-based file system, it takes the ONTAP approach, which is doing data level disaster recovery, and with that on the block level. So how does it address the application DR concerns? First of all, it is a lot less complex because you are focusing on the infrastructure and the data level, meaning the application itself can be built up separately. It is decoupled from the data. The data itself is replicated to your DR site at whatever interval you choose.
Danny, does that mean that it works the same for both file and block?
Yes, because it is done on the block level, i.e. replicating blocks at a time, and we'll get over to that at the webinar. Essentially, it supports both use cases. Because we're working at the block level, our recovery times are much faster because it's easier to move our data around to make sure that the data is synchronized between our between our source system and our destination systems, and it's easier to make things synchronized. Also, the granular protection at the data level ensures that there's a complete protection of the data, which is the important part of our application, our business data. That's usually where the golden eggs lay. That is the approaches to protect what's really important, and what's therefore is removing much of the complexities. And last but not least, when it comes to DR drill, another great ONTAP feature is, those of you who know ONTAP might know it as FlexCloud. You can create lightweight data copies of your data, writable lightweight copies of your data, and they test the DR plan on your DR side. On one hand, you get to make sure that you can fail over to in time of disaster. And on the other hand, it's lightweight, and therefore the storage penalty is quite minimal indeed. Now that we've talked a little bit about the FSx for ONTAP approach, but what is FSx for ONTAP? FSx for ONTAP is an Amazon storage service, an AWS storage service. Even though Esti and I work for NetApp, and this is a NetApp webinar, the service itself is 100% AWS, managed by AWS, a managed service by AWS that you can find in your AWS console right now. If you've opened your AWS console, you know that AWS divide their different services to main categories such as compute, such as networking, databases, etc., and of course storage. The most famous storage service is of course Amazon S3, and for the block storage, there's also Elastic Block Service (EBS), and there's the file system services such as EFS and all the FSx family. Part of the FSx family is FSx for NetApp ONTAP, which is an AWS service, but with NetApp ONTAP running under the bonnet. And what does that great combination give us? It gives us an intelligent storage service for your AWS workloads, you get a comprehensive set of features derived from AWS and from ONTAP. You can optimize it for cost and performance, and you also get the resilience and accessibility that comes with it. For accessibility, Esti already hinted at that. You get file, you get block and object storage. You get multi-protocol access such as NFS, SMP, and S3 if you want your AWS services to access the data easily. You get resilience and protection, which we're going to talk about today. And data security, which is more protecting the data from negligence and malicious factors, making sure that the data is accessible only to those who require access to the data, not to anyone else. Balancing between price and performance if we have high performance use cases, or if we have something which requires a more economical approach. And last but not least, data mobility and copies. How do we move our data around, share it between applications, introduce it to edge locations, etc. But the webinar today also obviously has a time limit, so we're going to focus on disaster recovery today. And now we'd like to, before we continue, going to have a poll talking a little bit about the way you work with you work with FSx. So we'll just so essentially our question is, how do you manage your FSx workload? Are you using the ONTAP CLI? Do you use the AWS Management Console? Do you use System Manager? Or you're not managing FSx at all, which is also perfectly all right. So we'll give you a minute to answer the questions, and then we'll continue. Okay, Esti, so I've mentioned the approach of FSx for ONTAP when it comes to disaster recovery. Can you explain a little how does it work under the bonnet? What's the technology that moves it about, and how does it look like in a high-level approach?
Absolutely. So when we're talking about FSx for NetApp ONTAP, initially we want to create a mirror of our data on a secondary site. Let's move to the next slide. Okay, so a mirror of our data on the secondary side is done with a technology named SnapMirror. SnapMirror essentially is a block level replication that takes all the blocks from our primary site and creates incremental copies of the data to the secondary site. And again, to highlight, it disregards whether it is file or block. If you're using the FSX for ONTAP for your databases or you're using it for file shares, it will take everything as is and copy it to your secondary site and will be ready on the DR site for whenever you need it. Now, how do we define our application? So that would be using, that would be using a user-defined schedule. Now, what does that mean? That means that we can either copy every 5 minutes if this is our RPO, or it can be once an hour, once a day, or even once a week. So this is really, really flexible, and you can define what would be your RTO and RPO and how frequently you want to copy the data to the DR site. Now, when the data is already on the DR site, what we have is essentially a read-only copy of our data. This copy of the data can be accessed at any time, whether it is with your SQL or any database. It can be accessed with a user using SMB or NFS, but it cannot be modified. So you can just access it, read it, validate that it's there, and then decide what you want to do with it. But what happens in case of a disaster? In case of a disaster, you can turn that additional copy of your data that would be, as we said, on a secondary region into a read-write mode. And then you simply redirect all of your users to use the secondary file system. Now, if it sounds complex to configure, we will cover all the options that are available today for you in order to create this DR topology and architecture. So without further ado, let's see what are the different options in order to define this and configure this architecture.
Okay, so how do we implement it? So we have three ways, three approach, which obviously have similarities. I would say there are two kinds of people in our world: those who come from the ONTAP background and those who come from an AWS background. So, Esti, since you have a very strong ONTAP background, I guess your approach would be basically use the ONTAP CLI, just as you would in any ONTAP system. Is that true?
Yeah, absolutely. So if you have any experience with any ONTAP system, regardless if it is on-premises, CVO, any type of ONTAP, ONTAP is ONTAP. And if you're familiar with the ONTAP CLI and with the old ONTAP commands, you can just use exactly the same commands. So we are talking about creating a jump host in order to connect to your FSX system. Then from that jump host, you can just connect with SSH and using the old familiar CLI commands, including the creation of the peer between the clusters, SnapMirror create, SnapMirror initialize, all those great commands that you might be already familiar with, you can create that SnapMirror. But if you don't have the ONTAP experience, let's see what are the different options for you to configure this.
Okay, so let's talk about the AWS approach. Unlike Esti, my background comes more, I have more experience with AWS than I do with ONTAP. So my approach is, since it is an AWS service, as we've mentioned, why not use AWS tools? And one very famous one very famous tool when it comes to automating our AWS resources is CloudFormation, which is the infrastructure as code service introduced by AWS. How would we go about using that? So first of all, AWS CloudFormation is the infrastructure as code service, and it can automate any AWS process or processes in any AWS service. And the idea is, as the name implies, to form and deliver and create AWS resources that work and synchronize together. Noticing that, we at NetApp released custom resources for CloudFormation that unlock advanced ONTAP features. One of them is SnapMirror for the NetApp users in the audience. Snapshots are also available, making CIFS shares, etc. All you need to do is go to the CloudFormation page in the region of choice, and search for NetApp in the custom resources, and you'll find what we've released. Basically, as I've said, you can use the custom resources and you can create a snap mirror relationship between your source FSX for ONTAP file system to your destination FSX for ONTAP file system. As simple as that.
And of course, guys, you will get all the links both to the snap mirror documentation and the CLI commands, and for the cloud formation. All of that will be available for you. So stay tuned. We will send it over once we're finished.
And if you are not comfortable with the ONTAP CLI and you're not working with CloudFormation yet, or at least don't have any experience with that and would like a more simpler approach with friendly UI, etc., we also have something for you called BlueXP Workload Factory. BlueXP Workload Factory is a service that that provides workload optimization and automation that helps you administrate your FSX for ONTAP file systems and fine-tune them for the relevant workload that they're hosting. There are a plethora of workloads that you can use there. You've got databases if you want to work with AWS Gen AI services, that we've got you covered there as well. And if you want to set up a SnapMirror relationship between your FSX file systems with a very easy to use and to learn UI, then BlueXP Workload Factory got you there. And you can basically use the UI or REST API, industry standard REST API. And we've got news for you. Recently, we've added a cloud shell. So if you're a little bit snobbish like Esti and prefer to use the ONTAP CLI, you can go to BlueXP Workload Factory. On the one hand, use the UI. On the other hand, you can automate and work with many systems together by opening the cloud shell and using the ONTAP CLI there, administrating many systems at once, something which is sometimes a bit difficult doing with a jump host.
And of course, without the need to deploy a jump host. That is the benefit of using the cloud shell in Workload Factory.
And you know what's the best part about BlueXP Workload Factory?
Tell us.
It's absolutely free.
Yay.
You don't need to pay a dime, and you can even use some of the features without giving any credentials, and some of the other features only with read-only credentials. So you don't have to trust us on day one. Just open the link and start see how it can help you.
Essentially a gradual trust model.
Exactly.
Sounds good. Thank you.
Before we continue, as we said, setting up DR is not a straightforward task, and when you're building your DR site, there are also some considerations you should consider before advancing. So first of all, before you do anything, choosing your disaster recovery region. There you have three main considerations. One, compliance. Are you allowed to use the geographical location to store your data? Two, networking. You're working for some of your clients, or your client-side applications are accessing the resources from somewhere. What is the best geo when it comes to latency and networking? There are many online tools you can check that. And not all prices of all regions are the same. Especially if you work in large scales, those differences can accumulate. So you better check the fastest and most economical region for your workloads and for your needs. Another one, sizing your DR file system. The naive approach, or sometimes the approach that comes from the on-premises world, is that the DR site should mirror the production site. But we're working in the cloud. We are elastic and flexible, and there's no reason to spend more than we need. So the DR site, the DR file system, should be as minimal as possible. And you should use the most economical storage tier that FSX has to offer, and put the data mainly on the capacity tier. When you need to fail over, use the elasticity and flexibility of the cloud and scale to the size you need to support your customers' latency needs, etc. After you set up everything, you want to test your DR site and make sure everything is ready. So use lightweight data copies of your DR for your DR drill. The NetApp people in the audience, once again, I'm referring to Flex clones. And last but not least, when the disaster hits, the most important and scarce resource you have is time. You need to fail over as quickly as possible and minimize downtime. Therefore, make sure that your failover plan is as automatic as possible, minimizing on manual work. Manual work takes time. It is prone for mistakes and is definitely not recommended should you need to fail over.
So Danny, what do you think? Should we maybe demonstrate everything that we talked about, how we can do all of that in minutes, fully automated, enable the tiering, which will reduce the cost, replicate everything with a nice UI?
Yes, I think we've talked too much and it's time to get our hands dirty. So with that, Esti, I will give you control. So let's take a minute here.
We're now looking at the homepage of the Workload Factory. The first thing I want to do in order to set up a replication relationship between a production system and a DR system would be to go to the storage inventory, where I can see the list of all the different FSxN systems that I manage. So let's click here on Go to Storage Inventory. A list of all the different FSxN systems that I manage, it appears here. And if I want to filter it by different regions, I can select multiple regions or just keep one selected, as we have in this example right here. If I scroll down, I can see I have demo prod system. This would be my production system for this demo, and demo DR FSxN system. Both systems are located in Oregon, which I will say it is not a best practice, but I did have to use it for this demo. I would highly recommend to consider having a secondary system in a different location. So what I want to do now is go to the demo production system and see the list of the different volumes I have there. Let's go all the way to the right and click on Manage. The screen I've been redirected to is the overview page. I can get a lot of information about my system from this page, but right now we just want to focus on volumes. So let's switch to volumes and see which volumes we want to replicate. In this system, I have only one volume, and this volume is named vol sift. As the name implies, this is a sift share. Let's take a look at what we have in that volume. So I will open my Windows host, and I will look at my volume sift share. Inside that sift share, I have an impressive collection of panda pictures. And this extremely important collection needs to be replicated to my DR site. I will minimize my Windows host. Now, if I want to create a snap mirror replication relationship for this volume, I can go all the way to the right, click on the menu, go to Data Protection Actions, and click on Replicate Volume Data. This will redirect me to a replication wizard specifically for this volume. I can also click on Replication Relationships and go with Replicate File System in order to create a replication relationship for all the different volumes that I have on my system in one simple wizard. In this wizard, I will select my source system. I will select the region of my destination system. As we said, this one is also Oregon. I will select the destination system. This is my DR system, demo DR. And I will also select the name of the SVM on my destination system. Since I have only one, it's a very easy choice. The naming convention for all the new volumes that will be created on my secondary system would be same volume name, then underscore copy. The next step would be to define the tiering policy. If you remember, we talked about different ways to keep the cost of our DR site as low as possible. So one way to achieve that would be to leverage the capacity pool. That means that instead of using the more expensive SSD drives, we're putting almost everything we can on the object storage. So the different options are either go with automatic tiering policy, snapshots, no tiering policy at all, or all. All means that we're leveraging the capacity pool to the maximum and keeping the cost of the DR as low as possible. So we would select this option and continue. The max transfer rate, as the name obviously implies, defines the transfer rate of our replication. If I go with the limited option, that would probably be because I'm afraid to affect the workloads currently running on my production system. If I go with the unlimited option, it is probably because I want to copy everything to my DR site as soon as possible. For this demo, we will select the unlimited and continue. The last two steps are the replication interval and long-term retention. The replication interval essentially defines my RPO. If I go with every 5 minutes, that means that the latest point in time to which I have to restore my data in my DR site would be 5 minutes ago. But when we go with every 5 minutes, we might affect the workloads running on our production. So in many cases, we would recommend to go with the hourly interval, which is for most customers is good enough with the RPO, and still doesn't affect too much the FSxN system. The last option is the long-term retention. By default, a DR site has an exact copy of the data that I have on my production site. It is a one-to-one copy. But if I want to create a backup copy of my data with longer retention and essentially turn my DR site into a remote backup system as well, I can enable this button here. And then I have more point in times and more snapshots stored in my DR rather than my source. In this case, I just want to keep it a simple DR, so I would leave this option disabled. Now, when this form is filled, I can either click here to copy the API request, and then I can incorporate this API into my infra as code tools, or I can go with the automated version and simply click on Create if I have the right credential for Workload Factory. Let's continue with the automated version for this demo. Let's go to the DR system and check it out. I will enter my DR system. I'll click on Manage. I will switch to the volumes view. And hopefully we will see the new volume. So now my volume is created and I would like to check the details. So let's see the volume details. And if I go here, I can see the volume type listed as DP, data protection volume. It means it is a read-only volume exactly as we wanted. And now we'd like to check that there is a replication to that volume. Let's close the details and check the replication relationships. Here, I can see that a new replication relationship has been created. Vol-sifs is replicating to vol-sifs copy. The status is success. It means everything is replicated. And I expect to see my impressive collection of panda photos on my DR system as well. In order to validate that this new volume has the same data as the source, we first need to create a SIFS share. So this volume is accessible from a Windows machine. Let's go to the volumes. Go to the options, and under advanced actions, I can find manage SIFS share. Create a new SIFS share. The name of the share would be vol SIFS copy, and I will click on create. My SIFS share has been created, and now I would like to see the content of that volume from my Windows host. Let's go back to the Windows host. Would like to map a new drive. vServer demo DR FSxN, and the name of the volume would be vol SIFS copy. Here is my new DR system, and as I can see, exactly the same photos appear here. So everything has been replicated. Now, note that this is a read-write volume, while this one is a read-only volume. So if I'd like to, for example, create a new text file on my source, we'll call it test, I won't be able to create anything here because this is a read-only. If I go back to my replications and update the relationship, I expect to see the same file replicated to my destination. Now, what happens if I want to make this destination a read-write? For this, I need to break my relationship. So let us minimize, go here and see the different options. I can break the relationship. That means it is no longer copying data from the source to the destination, and the destination turns into a read-write volume. I can reverse the relationship to make the DR as the production, the primary side, and the original production side to be now the destination, the DR. Let's break. And we'll go back to our server. Now, this has turned into a read-write volume. If I want to create something new,
Thank you, Esti, for that lovely Panda-themed demo. Now let's go back to that deck. Just a minute. There we go. So, as I think that was mentioned in the chat, you are going to get this deck, and in the deck we have left some resources for everything that we've talked about, from the SnapMirror CLI commands to different tutorial in AWS, and to the BlueXP Workload Factory documentation, and of course to our CloudFormation GitHub resources. I do believe all the questions have been answered by our great chat responders. Thank you very much. Thank you very much, chat responders, for answering very quickly. And I'd also like to thank you, all the attendees, for coming, for asking questions, for making this a more interactive session, for answering our poll, and for taking part in the webinar. We're looking forward to see you in future webinars. Thank you very much, and see you soon. Thank you, Esti.
Thank you so much. Have a wonderful day, everyone.
Thank you, and goodbye.